Hello, my name is Rita Leitze, and I will be presenting our work on offline reinforcement learning for shape control of deformable linear objects from limited real data. We present this problem as a bimanual planar control problem with 6 degrees of freedom. This setting precludes the need to re-grasp, but brings some challenges, namely the middle part of the rope is not directly affected by the movement of the grippers. And then also, because it's always on the plane and touching the surface, then there's some effect of friction that allows for the curvature reversal. So this is in contrast with previous work, which has tackled more of a grasp and pick and place type of operation. I will skip the details of the tracking based on the method by my collaborator, Shatab Sherry. We formulate the problem as an MDP, a Markov decision process. The state is the end effector positions and orientations, the current ones, as well as the current shape of the DLO, and as the goal shape. So we have a goal condition setting. The action space is the desired poses of the end effector, and then the reward function is just the root mean square error of these two shapes. Because offline reinforcement learning requires a static data set, we have to guarantee some adequate coverage of the state action space. And for that, we define a set of safe end effector poses, and we sample randomly from that. For each episode, we have some probability of sampling left, right, or both grippers, and also a smaller probability of executing a semi-random motion that inverts the DLO curvature. And then we just use point-to-point motion. So 1,000 episodes for training and validation, and 10 were used just for testing. We also try to augment the data by randomly sampling intermediate shapes and recomputing the reports. So here we see the effect of that. We then perform experiments without resetting the shapes, and we test the effect of the data augmentation and the behavior cloning regularization of the offline RL method we use, the TD3 plus BC algorithm. Here we see that in all cases, the offline method actually allows to learn the reversal of this DLO curvature, although it actually has a bit more jitter at the end. It doesn't converge as well as the baseline. We see the reversal. The best result is shown here. On average, our method is better. For 4 cases, it actually performs worse, but in a marginal way, whereas when our method does better, then it does significantly better, especially because of the failure to reverse the curvature, as I previously mentioned. Thank you.